Good afternoon. My name is Helen Kardiasmenos.
And I'm Annie Martin.
And we're from PLC Sydney. And today we're going to present to you on Storytime STEM.
But before we start, I'd like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. I pay respect to elders past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islander peoples today.
So what are we going to talk about today? We're going to start with outlining what Storytime STEM is. Then we're going to make some links between traditional reading strategies and the scientific inquiry skills. Following that, we'll be exploring Storytime STEM and STEM more broadly in the curriculum and looking at some examples of how we have done this in our classroom. So let's start with identifying what is Storytime STEM. So Storytime STEM is an interdisciplinary approach to using the STEM disciplines to explore problems and ideas in picture books and fairy tales. So we use the STEM in disciplines of science, technology, engineering and maths and integrate that with literacy exploration of text. So framing text with the scientific inquiry skills and reading strategies and using those as mirrors and a lens to explore texts, we encourage our students to solve problems in the texts and look at inferential comprehension, visual literacy and scientific inquiry to solve problems in our texts for our characters.
And before we start, I'll also just mention we're going to focus on 3 of the texts today that we have used, but you could apply it to any concept today to any text whatsoever. And in fact, this is a unit of work we do with Year 3 at our school. And in that unit of work, we also do a couple of other stories. We do Goldilocks and the 3 Bears, and we also do Incy Wincy Spider, and possibly a couple of others. But you could use any text that you would like to use. The concepts will still work out.
Definitely. All right, so the first thing we're going to do is link our reading strategies or our traditional literacy approaches to teaching comprehension with our scientific inquiry skills. So you can see when we're teaching children to comprehend and read a text using this Super 6 reading framework, we're asking our students to predict what's going to happen in the text, to visualize what might be happening in the story, to connect and make connections to both the wider world and perhaps other texts that they've read, to ask questions about what's happening in stories, to summarize what's happened in a story, and more importantly, to infer and have that guessing of higher order thinking of what's happening in a story. This actually mirrors quite nicely with the science inquiry skills.
Yeah, and you can see Helen's colour-coded it very nicely. So you can actually see that in any inquiry, so the experiments that we encourage the children to do, and in New South Wales, we call that the working scientifically. First, we question and predict, we plan and conduct the experiment, we evaluate, communicate, and obviously as part of that, prior we actually would have processed and analysed data to be able to do that. So you will be able to see that those link beautifully to that Super 6.
Okay, so deconstructing this a little bit more.
Yeah, so in science, when we teach science, there is probably 3 main sections. The 2 main ones are in our syllabus, which are about the science understanding, which is simply the content, and the science inquiry skills, which is pretty much the experiments. And all of this we like to frame as science as a human endeavour, where we sort of focus on actually being a scientist and what it's like being a scientist, particularly in the real world. And in all of that, the graphic is an Akara graphic, is that right, Helen?
Yes,
yeah.
right.
And we, as mentioned on the previous slide, they're the sections of science inquiry that we like to focus on, which we will cover as well as content in our Storytime STEM unit.
Now, looking at technology, our technology curriculum is framed around 2 disciplines, an ICT capability framework and a digital technology framework, which is embedded as part of our outcomes. Now, within our ICT capability framework, we're actually teaching our children to learn how to select ICT tools for specific tasks and use those as a way of communicating and expressing their understanding of their ideas. We're also teaching our children to code or to look at that digital literacy that underpins our technology use. So really these both are frameworks of skills and emphasises a way of thinking that's important to creating solutions. Underpinning both of these areas is this idea of computational thinking. And this runs across the Storytime STEM unit, where we're actually encouraging our students to understand the science behind what's happening in the story and then create solutions for their problems in the story using digital technologies and ICT.
And I'll just add to that too, at our school, Helen focuses on the technology and I focus on the science. And I know when a lot of people hear the word coding, a lot of people will actually freak out a little bit. But in primary school, particularly in the lower stages, that coding is really about algorithms and
sequential thinking.
And teaching their kids algorithms and things like that so that they can eventually do the coding. So don't be put off by the word coding.
Yeah, definitely. All right. Now, when we're looking at E for engineering, we're really looking at our design thinking and our systems thinking framework. So our design technologies curriculum encourages our students to use design and systems thinking to generate design ideas and communicate these as a way of creating solutions to problems. This includes selecting and manipulating a range of materials, looking at different systems and components, and looking at different tools and equipment that they could use to help generate a solution to a problem. Now, using this design thinking framework, we structured our Storytime STEM unit around students investigating texts and creating solutions for the characters in the texts using the framework. And then when we're linking back to maths, we're thinking about how our students are applying mathematical understanding, both creatively and efficiently. So again, using that skills framework of developing an understanding between the concepts that we're exploring in maths and then the concepts that apply to other areas of the curriculum, looking in the fluency of how we carry out procedures, how we use numbers flexibly, how we recall factual knowledge and concepts readily, and then applying that to problem solving and reasoning. And this is how we integrated our mathematics into our Storytime STEM unit.
And it's also important, if you look at that little wheel there, that the general capabilities surround that wheel. So obviously there's explicit teaching within your mathematics lessons, but the general capabilities which appear in the syllabus for science and other obviously KLAs, it's really important that we approach the numeracy and the literacy in other areas as well. And that's why that little general capabilities is mentioned there.
All right, so we'll start by looking at some examples of how we integrated Storytime STEM and our interdisciplinary approach to different texts that we use. So the first text we're going to look at is Jack and the Beanstalk. And Annie will start by talking about some of the science foundational concepts that she explored with the girls using this text.
So actually earlier in the year, in year 3, we focused on gardens and growing things. So the way we actually approached the start of this unit of work was by reminding them of how we grew plants, and we gave them some beans as a bean growing challenge. And we wanted to talk about how beans can actually bean plants can actually grow really, really tall, even though they don't have a big thick trunk like a tree may. And then we gave them the challenge. I gave them 2 seeds, one which you just bought from a supermarket where you had just normal dry seeds that people would soak and actually use in their cooking, and also some from, Bunnings or places like that where they bought bean seeds. And then we gave awards for the tallest bean plant. So that was a catching thing. I liked that as a concept because we were looking at the tallest stem, and this was our first way of teaching the children about the importance of STEM, STEM, with capitalized obviously, so standing for the things that it does, comparing it to STEM lowercase, where like linking it to a part of a plant. We also really focus on teaching aspects of the skills in science. So for example, scientific diagrams, the children focused on that as well. And we reminded them of parts of a plant, which we then also linked to a little design task, which we had quite early in the section of work as well, where I gave the children 20 pipe cleaners, and we asked them to make, with a partner, to make the tallest stem that they possibly could. And again, that word STEM can appear in different ways, because to get at the tallest STEM, they had to design a solution, they had to think about the science that they learned, and they had to measure. So even in that task, there's both forms of STEM. And when we gave the pipe cleaners, most of the children were able to work out at the base of it. They needed some kind of a root system. You can see this on one of the images on this slide. But the better students in pairs, we had pretty much one in each group, worked out the importance of tendrils. And they did have some real life plants to look at, which did have tendrils as part of their learning. And they were able to see that to apply what was in nature to these tall plants was also, you know, a really good part of their learning.
So picking up from that learning in digital technologies, we actually started exploring, well, how could we help Jack transport things down the beanstalk, looking at the strength of the actual beanstalk and looking at the length of the beanstalk. The students used an engineering process and some brainstorming and working in sprints, design sprints and groups. They came up with the idea of creating a digital crane using the We Do system to help Jack transport things down the beanstalk. So this activity in itself involved the design process as the engineering element of our STEM. There was quite a lot of maths involved because the students had to measure and think about, well, how tall would the beanstalk be? So therefore, how big should our crane be and how quickly should it move? And then also integrating our digital technologies here of algorithms and programming. So on the one hand, the students were following an algorithm in order to be able to create the Lego We Do crane. And then on the other hand, they were creating their own coding or programming to be able to move the Lego We Do crane. So integrating their knowledge from science, they were able to build a digital solution for Jack in the story. So this is an example of one of the students' cranes.
And this is our basket for the chicken and Jack to go in.
Okay, so the next text that we worked with was Matt Shank's story, Row, Row, Row Your Boat. And Annie will talk about the science behind this text.
So this is a version of Row, Row Your Boat, but it's really the illustrations in this that I used as the key for the science learning. Scientists need to be observant and they need to question, like they're two, and then they need to test to find out what their thinking was. And if you look at the images from this text, you will see that the title page one has got all these animals in it, and you see the height of the boat compared to the water. And then the next image has the little boy in the boat, and the water is at about the same level on the boat. So I read them the book, the children were engaged, and then I told them that I was actually concerned about the images because they didn't tell the story that I thought science would actually tell. So then what we did is I gave the children little tin boats, and we had little buckets for water and got little counters like you would have in maths. And I asked them to see if the images were right or not. And as they put more in, they did notice that the little boat went down. Obviously, I said, that's okay, that's artistic license, and they're allowed to have them not right. But I just pointed out that my scientific mind has me questioning things. The other thing that I did is I asked them then, challenged them then to fit as many animals in that little boat as possible. So there were different sized animals that they had. So again, this comes to the maths, and it was about them selecting the smaller ones if they wanted to fit as many in as possible.
And also using those informal measurement tools that we teach our students in the younger years in measurement and geometry, and then looking at using formal measurement tools as well. So in digital technologies, we picked up the learning around the buoyancy and the sinking of the boat. And we talked about how we could create a solution to help our characters solve their problems. The students working together after we'd done a little bit of learning around networks and digital systems had decided, well, what we could do is create some kind of communication system in the form of something like a ham radio or a networked radio that the characters could use to call for help. So using the microbits, the students coded 2 microbits and the radio feature on the microbits to create a two-way communication system as a way of asking help. We also explored different types of communication systems and started learning a little bit of Morse code with this activity. The other solutions that we came up with was to design our own boat. And the students observed that in the text, row, row, row your boat, it was quite a simple boat made of wood. So they wondered if a digital boat or an electronic boat would be more successful for our characters. So we used the Airblock drone and we reconfigured parts of the Airblock drone to create a hovercraft speedboat, and then took it into our pool at the school, and the students then created different codes to be able to save drowning rubber ducks with the hovercraft boat. The other solution that we came up with was using the Merge Cube. They designed a prototype for a digital boat in Merge Dig and built this in augmented reality, as you can see in the image here on the left. The last text that we explored was The Three Little Pigs. And Annie will talk a little bit about the science, and then I'll link it back to what we did in technology.
So across all of the stages in the primary school syllabus, material choices is mentioned. It's really important that the children understand how materials used for different things are not just random, but they're selected to suit the purpose of what they're being used for. So this story was absolutely perfect. 3 houses made from 3 different materials, and they stood the test in different ways. But a big part of what I believe one of the best things that a primary school teacher can do for their children going into high school is teach them scientific method, the science inquiry skills, so that they can design fair tests and test things out for themselves. So that was the primary focus of the science in this. So you can see the children making the 3 different houses here. We had a straw house, a stick house, and a brick house. And I had some tiles and sticks and things. You can see what I've used there with the children. But the key thing was each house was built on the same foundations, which is the same size plate. They all had the same amount of Play-Doh as the base. They also had the same height walls. None of them had walls. None of them had doors. They all had the same amount of tape to join them together. And they all had a roof made out of the same material. So everything about the design of the houses, so we could test them fairly, was the same. And then we read the story together, and we had students acting out being the 3 little pigs, and we had one being the wolf, and that person held the hairdryer. Again, so it's a fair test, and an equal amount of air could be blown at each. And they then tested for the same amount of time of blowing and the same distance from the houses, which house would actually stand the test the best. So it was just a really good way of testing what that traditional story is about using the science.
And then what we decided in technology was it would be great if the pigs had some kind of warning system of the wolf's arrival. So the girls decided to create an interactive warning system using the Makey. So we built a pressure pad with cardboard and foil, and then the girls created different types of coding to set off an alarm to show that the wolf had arrived at the doorstep of the pigs. So this particular activity really integrated a lot of the learning that Annie had instilled in the girls around the material choices, in terms of what material choices we use to build our digital system, also looking at the engineering process of using the design process to test out and then reiterate our design and our code, and then looking at the combination of the digital system altogether. So it was quite an engaging activity. It was a really interesting activity to see how the girls had applied their coding and how they actually used the design process to build their pressure pad to create that warning system for the pig. Okay, so if you do have any questions, please feel free to contact us. Our details are on the slide, and I will just end with a video of the girls making their